Hello friends, welcome to our channel Aha Zindagi Edu-Care. Today we will discuss binomial theorem. In binomial theorem, we will discuss what is a binomial expression, what is a binomial theorem. We will see the expansion of a binomial expression. Then we will see applications of binomial theorem. We will see how to calculate the rth term in a binomial expansion. Then we will also see how to calculate the middle terms of a binomial expansion. Okay friends. So what is a binomial expression? We will start with binomial expression. So what is a binomial expression? See, any algebraic expression containing two terms is called a binomial expression. So any algebraic expression, let it be a plus b, 3x plus 5y, x plus 2 by y, y plus 3 by x. So any expression containing two terms, okay? Any expression containing two terms is called binomial expression. Two terms, okay? And what is a binomial theorem? It is binomial theorem. Okay. So what is a binomial theorem? The general form of a binomial expression is normally x plus a. Okay. And the expansion of x plus a to the power n. So expansion of a binomial expression. Expansion of a binomial expression of x plus a to the power n. N is an element of natural number, is called binomial theorem. Okay. So how to calculate or how to expand the binomial expression? See, if formula is simple like x plus a to the power 0, we know it will be equal to 1. First we will clean here, then we will, okay. So see, if there are only few terms or indices is lesser, x plus a to the power 0, we know it will be equal to 1. If x plus a to the power 1, we can write it easily as x plus a. Okay. Then when the indices is 2, this is 2, okay, power of x plus a. We can write it as a square plus b square plus 2ab. So 2ax plus a square. It is okay. Then come to the cubic expression. We can still remember the formula x square a plus 3x a square plus a cube. Then x plus a to the power 4. So what we can do, we can even multiply x plus a whole square twice, okay. So x plus a whole square into x plus a whole square, When we multiply these two terms, we will get x to the power 4, 4x cube a plus 6 x square a square 4x a cube plus a to the power 4. Okay, so till now it is okay, but for the higher powers, how we can calculate? We will see it later. Now we can see here index, okay, and coefficients of various terms. It is index of binomial, and coefficients of various terms. So it is C. It is the one. So we can write for index 0. It is 1. For index 1, see coefficient of x is 1 and a is also 1. Next, for index 2, this index 2, first x square coefficient is 1, then it is 2, and again it is 1 for a square. For index 3, we have, see, 1, 3, 3, 1. And for index 4, we can write 1, 4, 6, 4, and 1. Okay. If we see here, see 1 for 0, 1, then for x plus a to the power a 1, it is 1, 1. Next, if we see, it is, see, middle term is addition of this and this. So this addition, again if we see here 3 is addition of 2 and this, so this plus this. Okay, similarly here you can see this 3 plus 3 will give 6, and this 4 came from 1 plus 3. So this pattern is called Pascal's triangle. Pascal's triangle. Okay, from this we can easily expand. We will now generalize this to higher powers. Okay, we will move to higher powers, then we will see how to expand. Now if we see index of the binomial, index of the binomial, and here we will write coefficients of various terms. Coefficients of various terms. Okay, now for index 0, 1, 2, 3, 4, 5, 6. Okay, so we have seen up to 4. Here for 0, it will be 1. Okay, for 1, we will write 1, 1. So for 2, we can write 1, 2, 1. How we get it? See, summing 1 and plus 1 will give 2. Then again we will see here. We will sum, so it will give next term. For 3, it will be 1. See, 1 plus 2, 3. Then 2 plus 1, 3, and 1. So for index 4, we can write from here only. We will 1, then we will sum 1 and 3. It will give 4. Then we will sum up 3 and 3. It will give 6. And then we will sum up 3 and 1. It will again give 4 and 1. For index 5, if we do like that only, 1, then it will give 5. This will give 6 plus 4, 10. Again here it will give 6 plus 4, 10. And 4 plus 1, 5. Then 1. For index 6, we can write 1. Then 1 plus 5. It will be 6. 5 plus 10. 15. 10 plus 10. It will give 20. Then 10 plus 5 will be 15. And 5 plus 1, 6. Then 1. Okay. So like this, we can go for calculate for higher terms also. But if the index increases to higher numbers, it will be difficult to form and calculate based on Pascal's triangle. So this is your Pascal's triangle. Okay. So for index, or we can say for lower index, we can calculate from Pascal's triangle. But for higher powers or higher index, we need to use binomial theorem. Now we will see how to expand a binomial expression using binomial theorem. Okay, friends? So next we will start with binomial theorem. Binomial theorem for positive integral index. Okay. So the theorem states if x and a are real numbers, okay, if x and a are real numbers, then for all n which is a natural number, okay, we can expand using this theorem. X plus a to the power n will be equal to nc0 x to the power n a to the power 0, okay, plus nc1 x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2 plus similarly for ncr x to the power n minus r a to the power r. Similarly, second last term we can write nc n minus 1 x to the power 1 a to the power n minus 1 plus ncn x to the power 0 a to the power n. Or we can write in a condensed form x plus a to the power n equal to, using summation we will write in condensed form, r varies from 0 to n, ncr x to the power n minus r a to the power r. Okay, friends? See, this theorem can be proved by using principle of mathematical induction. Okay, and here if you see ncr, okay, so how do we expand if ncr I will write it as n factorial by n minus r factorial into r factorial. See, this formula you need to remember. I suggest all of you to go through my lectures of permutations and combinations to understand this formula. Okay, friends? I will put the links in the description box. Please go through the chapter permutations and combinations. Then you will easily understand this and this chapter will become easier for you. Okay. Now if we see this binomial expansion, we can conclude, so some conclusions I will write. Okay. See, first conclusion, if we add sum of indices, if we add index of x and index of a, everywhere you see n minus 1 plus 1, it will be n, here also n minus 2 plus 2. So first conclusion is sum of indices of x and a in each term is n. Okay. Second thing you can notice, as we know NCR equal to NCN minus R. This is a property of combination. So please, again I suggest everyone to go through combination chapter. Okay. So if we see here, you see NC0 and NCN. So NC0 equal to NCN minus N. Similarly, NC1 equal to NCN minus 1. Okay. NC0 equal to NCN. Similarly, NC1 will be equal to NCN minus 1, NCN minus R. Okay. So from this we can conclude coefficient of terms equidistant from the beginning from the beginning and the end are equal. Okay. These coefficients we also called as binomial coefficients. So we can write coefficients or binomial coefficients. Okay. Next we can see, okay, we will clean here, then we will write. Third conclusion, see, if we place x, we know x plus a to the power n equal to, see, x plus a to the power n is equal to summation of r equal to 0 to n, and it is given as ncr x to the power n minus r into a to the power r. If we replace a by minus a, okay, replacing a by minus a, we can write x minus a to the power n will be equal to, if we see, we can write ncr x to the power n minus r and minus a to the power r. R varies from 0 to n. It can also be written as summation r equal to 0 to n, n or minus 1 we will take out from minus 1, okay, from minus a to the power r ncr x to the power n minus r into a to the power r. And if we expand this is in the condensed form. After expansion, we will get like nc0 x to the power n a to the power 0 minus. So alternate terms will be positive and negative based on the value of r. When r is equal to 1, it will be minus. So nc1 x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2 minus nc3 x to the power n minus 3 a to the power 3. Okay, friends. Similarly, if we expand, we will get minus 1 to the power r ncr x to the power n minus r to a to the power r plus last term we will get minus 1 to the power n ncn x to the power 0 to a to the power n. So this is expansion of x minus a to the power n. Next one, if we see here, see one more property is if we see the total number of terms, either we see x plus a to the power n or x minus a to the power n. So number of terms in the expansion is n plus 1. Okay, you can see r varies from, here you see 0 to n. So r equal to 1 to n will be n terms, and it is including 0 also, this term. So the total number of terms in the expansion is n plus 1. Next property we can see in this x plus a to the power n, if we put x equal to, when x equal to 1 and a equal to x, so we will get 1 plus x to the power n will be equal to nc0 as x equal to 1, so it will be 1 a to the power 0, so a equal to x, so x to the power 0 equal to 1, so it will be nc1 x plus nc2 x square. Okay, when r equal to 2, power of, here see x equal to 1 to the power n minus 2, so it will be 1 only, and in place of a it is x, so x to the power 2. Okay, for n r equal to r ncr x to the power r, and last term will be ncn x to the power n. Okay, next when we put r, sorry, when we put x equal to 1, 6, x equal to 1 and a equal to minus x, what we will get? 1 minus x to the power n equal to nc0 minus nc1x plus nc2x square. Similarly, we will go plus minus 1 to the power r ncr into x to the power r, and last term will be minus 1 to the power n into ncn x to the power n. Okay, the coefficient of r plus 1th term, if we see this term is r plus 1th term, this term, In 1 plus x, we can write the coefficient of r plus 1th term in the expansion of 1 plus x to the power n is NCR. We can see it from here. Okay. So these are few conclusions which we can draw from the binomial expansion or binomial theorem. Okay, friends. Now, based on this, we will solve few problems so that we can easily understand this. Okay. So we will take an example. First problem we can write expand 2x minus 3y to the power 4 using binomial theorem. So what we can do using binomial theorem, we can write 2x minus 3y to the power 4. We can write it as 2x 2x plus minus 3y to the power 4. Okay, and using binomial expansion, we can write first term as 4c0, as here n equal to 4. So when r equal to 0, 2x to the power 4 minus 0 and minus 3y to the power 0. Second term will be 4c1, 2x to the power 3 into minus 3y. Third term will be 4c2, 2x to the power 2 and minus 3y to the power 2. So first, second, third, fourth term is 4c3, 2x to the power 1 and minus 3y to the power 3 plus 4c4, 2x to the power 0 and minus 3y to the power 4. See, in each term, r, this is equal to r and this is equal to n minus r. Okay. So using x combination formula of NCR equal to n factorial by n minus r factorial into r factorial. So this formula we will use and calculate each coefficient. Now we will get 16x to the power 4 minus, see, in this term minus will come here. Okay, first we will multiply this one only. 4 into 2x, so 8x cube, 8x cube from this one into minus 3y plus 6 4x square to 9y square plus 4 into 2x into minus 27y cube, and last term we will get 4c4 will be 1 only, so 1 into 1, because 2x to the power 0 will be 1 and last term will be 3 to the power 4 will be 81y4. Okay, so after simplification we will get 16x to the power 4 minus 96x cube y plus 216x square y square minus 216xy cube plus 81 y 4. Okay friends, so this is how we can expand a given expression using binomial theorem. Next we will see a problem containing three terms. So how to expand that one? So if we have, suppose second problem, we have to expand using binomial expression 1 plus x square to the power 3. So we can write this as using binomial expression, binomial theorem. What we can do, we can take two terms as common. So we can write this in the form of 1 plus x square, okay, to the power 3. Or if we assume x plus x square equal to y, so 1 plus y to the power 3, where y equal to x plus x square. Now we know the formula of 1 plus x to the power n. So it is equal to nc0, so 3c0, okay, plus 3c1y plus 3c2y square plus 3c3y cube. And now we will substitute the value of y. 3c0 equal to 1 plus 3c1 equal to 3, and y is x plus x square. 3c2 is again 3, and y square will be x plus x square whole square plus x square whole cube. 3c3 is again 1. So from this we will get 1 plus 3 into x plus x square plus 3 into, we will break this one, x square plus 2x cube plus x to the power 4, and this again we can break either using a plus b whole cube, or we will use again binomial expansion. So if we use binomial theorem, we will write 3c0x to the power 3 and x square power 0 plus 3c1 x to the power 3 minus 1 x square to the power 1 plus 3c2 x to the power 3 minus 2 and x square to the power square plus 3c3 x to the power 0 and x square to the power 3. So this is how we can expand this. So again simplifying, we will get 1 plus 3 into x plus x square plus 3 into x square plus 2x cube plus x to the power 4 plus, now this again we will simplify, we will get x cube plus 3x to the power 4 plus 3x to the power 5 plus x to the power 6, and after adding similar terms we will get x to the power 6 plus 3x to the power 5, okay, x to the power 5, how many terms? Only one term. Then x to the power 4 is 3 and 4, okay, this is 3 terms and this one but multiplied by 3, so 6 x to the power 4 plus x cube, see 3 into 2 6, 6 and 1 x cube, 7x cube plus x square will be 3 3 6x square plus 3x, okay, plus 1. So Using binomial theorem, we can even expand a term containing three terms. Three, okay, this is trinomial expression actually, but we make it in the binomial form and then expand it. Next, we will see how to calculate. See, we can see the application of binomial theorem if we take a problem and say what is the value of 0.99 to the power 5. See, it will be difficult if we try to calculate 0.99 to the power 5, but using binomial expansion theorem we can easily solve this. See, 0.99 can be written as 1 minus 0.01 to the power 5, and it is equal to 1 minus 1 by 100 to the power 5. Now, using binomial theorem, we will expand this. So 5c0 minus 5c1 into 1 by 100 plus 5c2 into 1 by 100 to the power 2 minus 5c3. What we are using? 1 minus x to the power n formula. Okay. So 5c3 into 1 by 100 to the power 3 plus 5c4 into 1 by 100 to the power 4, and last term will be 5c5 to 1 by 100 to the power 5. Okay, it will be minus. So this is equal to 1 minus it is 5. So 5 by 100, and 5c2 we can calculate, it will be 10. So plus 10 by 1, 2, 3, 4, 0, and next term will be 5c3 is again 5c 5 minus 3 or 5c2, so it is again 10 divided by 10 to the power 6. So 1, 2, 3, 4, 5, 6. Next term is 5 divided by 100 to the power 4, or we can write it 100 to the power 4 minus 1. 5c5 equal to 1, so 1 by 100 to the power 5. See, these two power will be, if we see the ratio, it will be very less and we can ignore these last two terms. So it is equal to 1 minus 0.05. Even this will be very less. We can ignore this term also. So ignoring fourth and higher terms, plus 0.001, 1, 2, 3, 4. Okay, ignoring fourth and other terms. Okay, so it, after calculating we will get 0.951. Okay, so this is how we can calculate powers of 0.99. Similarly, if we come across, say, second problem, okay, 102 to the power 6. So again we can expand it using binomial theorem. 300 plus 2 to the power 6. So using binomial expansion, we can expand that as 6c0, 100 to the power 6 plus 6c1, 100 to the power 5 into 2 to the power 1 plus 6c2, 100 to the power 6 minus 2 equal to 4 into 2 to the power 2 plus 6c3, into 100 to the power 6 minus 3 equal to 3 2 to the power 3 plus 64 into 100 to the power 6 minus 4 equal to 2 to 2 to the power 4 65 into 100 to the power 6 minus 5 equal to 1 into 2 to the power 5 plus 66 into 100 to the power 0 into 2 to the power 6. So we can write this as, see, 6C0 equal to 1, so 100 to the power 6, okay, plus 6C1 equal to 6, so 6 into 100 to the power 5 into 2, and 6C2 will be 15 into 100 to the power 4 into 2 square plus 6C3 will be equal to 20 into 100 to the power 3 into 2 to the power 3 plus 6C4 will be 15 into 100 to the power 2 into 2 to the power 4 plus 6 into 100 to the power 1 into 2 to the power 5 plus 2 to the power 6. So this will be equal to 10 to the power 12 plus 12 into 10 to the power 10 plus 6 into 10 to the power 9 plus 16 into 10 to the power 7 plus 24 into 10 to the power 5 plus 192 into 10 to the power 2 plus 64. Okay. So after adding all this, we will get 1, 1, 2. See, 1, 1, 2. Then 6, 1, 6. Okay. 6, 1, 6 will come from here. Then 2, 4, 2, 4. 1, 9, 2 will come from here. 1, 9, 2, 6, 4. Okay, friends. So using binomial expansion, we can calculate the expansion of 100 to 101 to the power 6 or whatever is given. Okay, friends. Next, we will see how to calculate the our general term of a binomial expansion. So let's clean this. We will calculate general term in binomial expansion. Okay. If we see a binomial expansion, what we know, x plus a to the power n equal to nc0 x to the power n a to the power 0 plus nc1 x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2 plus ncr x to the power n minus r into a to the power r, okay, plus last term will be ncn x to the power 0 a to the power n. So we can see first term, what is our first term here? First term equal to nc0 x to the power n a to the power 0, okay. Second term is nc1 x to the power n minus 1 a to the power 1. Third term is how much? Third term equal to nc2 x to the power n minus 2 a to the power 2. So if we see for r plus 1h term, okay, see this is your r plus 1h term. So r plus 1h term equal to ncr x to the power n minus r into a to the power r. Okay, if in place of a it is minus a, we will replace it by minus 1. So in a binomial expansion, general term is given by tr plus 1 equal to ncr x to the power n minus r into a to the power r. Okay, this term is in x plus a to the power n. If we have to find r plus 1h term in 1 plus x to the power n, here tr plus 1 will be equal to ncr into x to the power r. Okay, replacing x by 1 and a by x. So in this way we can calculate any term in a given binomial expansion. Okay, so we will solve some problems based on nth general term of a binomial expansion. So if I say find the ninth term in the expansion, question is we have to find T9 or ninth term in x by a minus 3a by x square to the power 12. So we know tr plus 1 equal to ncr x to the power n minus r to a to the power n. So if we put r in r equal to 8, okay, we will get T9. So T9 can be written as T8 plus 1. So it will be, see, n is given as 12. So 12 C8 and first term here if we see is x by a. So x by a to the power 12 minus 8 into a is minus 3a by x square to the power 8. Okay, so this we can write as 12c8 to x by a to the power 4, and if we see this minus to the power even power will be positive. So 3a by x square to the power 8, and this we will get as 12c4 because ncr equal to ncn minus r into 3 to the power 8. See, here we will get x to the power 4 and here we will get x to the power 16 in denominator, and a to the power 4 here, a to the power 8, so a to the power 4 by x to the power 16 minus 4, 12. So T9 we can write as 12c4 into x to the power minus 12 a to the power 4 into 3 to the power 8. So this is how we can calculate the nth term or rth term. Next we will see, let's clean here. Find a if 17th and 18th terms in the expansion of, so T17 equal to T18 in 2 plus a to the power 50. So find a. So we can write T17 as T16 plus 1, okay, and n here is equal to 50. So 50 C16 into 2 to the power 50 minus 16 and a to the power 16. So T17 we got. Similarly, and this will be equal to 50 C16 2 to the power 34 into a to the power 16. Similarly, we can calculate T18 as T17 plus 1 is equal to 50 C17 2 to the power 50 minus 17 to a to the power 17, and this will be C17 into 2 to the power 33 a to the power 17, as T17 equal to T18. So we can write 50 C16 into 2 to the power 34 a to the power 16 equal to 50 C17 to 2 to the power 33 to a to the power 17. So now we will simplify this, or see 50 C17 we can write as 50 factorial by 34 factorial into 16 factorial into 2 to the power 34 into a to the power 16, and this will be 50 factorial by 33 factorial into 17 factorial into 2 to the power 33 into a to the power 17. So this, see 50 factorial will get cancelled down on both sides, and this 2 to the power 33 will cancel with this one a to the power 16, so a will remain. So now we can write 1 by 34 into 33 factorial into 16 factorial into 2 equal to 1 by 33 factorial into this 17 factorial we can write as 17 into 16 factorial. I repeat, please go through permutations chapter to know how to calculate factorial, okay, and properties of factorial. So this will be a. Now 16 factorial will get cancelled out on both sides. Similarly 33 will get cancelled out, and what we see this 2 34 so 17, and this 17 again will get cancelled out. So a will be equal to 1. Okay friends. So this is how we can find the general term in a given binomial expansion. I hope every one of you have understood the lecture. If you have any doubt or any query regarding this lecture, please let me know in the comment box. I will try to resolve your doubts. Okay friends? And if you have seen the whole video and liked it, please like the video and subscribe our channel Aha Jindagi Edu-Care. Also press the bell icon button so that you will get notification when we upload the next video. Okay friends, thank you.